All right, hey class, time for the Centripetal Force Lab. And so we have a couple pieces that we need to use for this. We need the photo gate, or the force sensor. We need the photo gate. We've got this, we're going to use this mass hanger, although it's not ideal. A string to hang it on, and then of course the 850 interface. We're going to take the force sensor and we're going to plug it into the Passport 1 port on the bottom left hand corner, and we're going to take the photo gate and we're going to plug it into the digital output 1 port. Okay, so what's the key things you need to do? So you hang this on here and everything, so this must hang straight down and it must be in the center of this photo gate. And due to the level of the desk and whatever, or the way the clamp works, this bar may or may not be straight up and down. And so you need to have this thing set so it hangs down there, so you may have to shim it. I have put a little piece of cardboard in here just to give it a little tilt that way so that it would hang straight down through the photo gate. So just keep that in mind. Now, in the photo gate, there is actually a hole over here on this side, and there's a corresponding hole on this side, and through there is a laser. Right, so you have a laser and a detector. And what this does is every time that it crosses the path, it makes it so that it disconnects that beam, all right? So it blocks that beam. And so you need to make sure that this piece right here, this bottom piece, is the one that's interfering with that beam. That's crucial. The other thing is this mass is not ideal, and you can see that this is 50 grams altogether, but the majority of the mass is down here. And so what I did is I actually just bounced this on my finger to find the center of mass, and I put a little mark there. And so now I know where the center of mass is, and that's going to be important when we figure out our radius. Alright, so now I can hang that back. And so now I've got everything kind of calibrated so that everything is working and good, and so it's pretty good. Now, one thing I'm going to tell you about when you actually do the measurement though. This thing may or may not necessarily be exactly straight up and down for what you think. You're going to see it on the graph, and the graph is going to look like a sawtooth as you see here, right? And so you got one big, one small, one big, one small. And so what you're going to have to do is, on your first run, you're just pretty much calibrating the system. And so you're going to want to pull that back, let it go, and then just kind of, if you see that's happening, just kind of give this thing a twist one way or the other to try and get that out. And I'll put a fast motion of me calibrating this one to this position so you can see what I mean. And you may have to do several runs just to get it in, but once it's in, it's done. And so now I can see that. So now what I'm going to do is I'm going to come up here to this force sensor, and I'm just going to twist it just a little bit in one direction. And I'm going to see if I can get those peaks to more or less be the same. So once you've hung this on there and everything is good, your thing is aligned and calibrated, fantastic, what you're going to want to do is zero this out. Alright, so once you zero that out, that is going to tell the sensor, hey, this is now zero. I want to get rid of this weight because, as in the, like on the first page of the lab, you see that the centripetal force is part tension, part mass times gravity. And so what I'm doing by zeroing that right now is I'm removing the mass times gravity portion so that force centripetal equals the tension. And that's it. So now we can actually do a direct measurement to see how that works and plays out. Alright, so with that being said, everything here is pretty well set up. Let's go ahead and start the capstone program. And we're going to come here, we're going to click on capstone. Alright, we can see the hardware thing is blinking. Let's go ahead and click on hardware. The force sensor is already there. So let's go ahead and click on this cog and, oh yeah, no. The force sensor is already there. Let's go ahead and click on digital input 1, and we're going to put one photo gate single flag. All right, that's the key for that one. One photo gate single flag. Now, the photo gate, let's go ahead and click on this cog right here. It's going to bring up this window. Photo gate just means it's going to, every time you interrupt it, it's going to basically be calibrating that speed. How long did it take? Now, the one thing you need to know about this is we need to know how long or how wide or the diameter of this thing so that we know how long it's going to be or what that length is that's interrupting that gate. And that is crucial. So you're going to measure the bottom of this, get that diameter, and you're going to put that diameter in this flag length over here, or this flag width. And so I measured mine already, and it was 375. All right, and so now I'm going to press OK. And so now I've set that flag length, this thing, I've set this width. So it knows how wide that is, or how, when it breaks the beam, it knows that change in X, or as it were. Okay, so let's go to data summary. And let's go to force sensor. Let's go here, numerical format. Let's make sure that's 3, and I see it is. So let's press OK. And everything else looks good. So I'm going to click out of there. Let's go down here to the bottom. So the high resolution force sensor, I want to be at 50 Hertz. So we're going to measure 50 times per second. And so now that's set. Everything is now set. So we're good to go. Let's go ahead and click into graphs. So we'll double click this graph in the top right hand corner. Double click it twice. So now we have 2 graphs. I'm going to come here, select measurement. This one will make the force graph. And I'm going to select here. And this one we're going to make the speed graph. So we want the speed. So now we have a force versus time and a speed versus time graph. So now we're good. Everything is set up. And I've shown you about the calibration, the twisting of this thing. So let's just go ahead and measure. So I'm going to pull this thing back here about 10 to 15 centimeters. You don't have to go very far. And this is one of the reasons why this is not such a great mask to use, is because this stiff is so long you can get this kind of rocking back and forth as it goes. And the force sensor will pick that up and measure it. If you raise the force sensor up to like 250 Hertz or whatever, you can actually see the little oscillations within the big oscillation. It's kind of interesting. But for us right now, I'm going to go ahead and, so make sure that when you do this, you align yourself nicely so you don't hit the photo gate, right? You want to pull it straight back, let it go so it goes straight through the middle. All right, so let's go ahead and do this. We're going to press record, and then I'm going to let that go. And we'll record for about 10-ish seconds. Excellent. Okay. Now, my graph is pretty good. Like I said, I've already calibrated. So I'm going to grab the axis numbers here and just spread this up so I can see what's going on. All right. And what you want to really make sure is you want to make sure this sine wave is pretty nice. If it's not, just go ahead and redo it again. And you can see like it has some wiggle, right? See how it wiggles right there when you do that? So that can play a part in this whole thing. So just either that or choose the spot that looks really good. And I'm going to choose like this one over here because that looks quite nice. This one looks pretty nice too. So let's choose this one. So I'm going to go ahead and put the highlighter box in. And I'm going to choose one wavelength only. Okay, so what is one wavelength? Like we talked about with the circle, right? We've got one wavelength. So we've got from the middle, down, back, and back. So we got one wavelength highlighted. And now what we want to do is we want to come up here to the force to this thing. And we're going to click on here, we're going to click maximum, minimum, and get rid of the mean. And then we're going to apply that. And so now we have the maximum force felt at this point and the minimum force felt at that point. You're going to record that in max n, min n on your table. So the other thing on your table is you've got so we already know that this is 50 grams. This is the first weight. And the one thing I didn't show you is we need to R. We need to know how long it is. And so we have the center of mass right here, right? And so what I'm going to do is measure from the bottom of the hook to that center of mass, which is roughly about, in this case, 22 3/4 inches. Now, as you know, we don't work in inches, right? So 22 3/4 inches translated into centimeters is 57.785 centimeters, and we work in meters, so we're going to do it again as 0.57 meters in my case. Yours will be whatever it is, but make sure you do this in meters. But this is going to be your R, right? From there to the center of mass is your R. All right, so now we have our R, we have our max, we have our min. The last thing we need to do is get our velocity, our speed. And so what we want to do is we want to look somewhere around 3 seconds, right? That's the middle of our box here. Let's go to the speed graph and we'll click a coordinate tool and we're going to look for somewhere around this time. So we know it's before 3.5 and after 2.5, and so let's maybe that one. So 2.74, that's like kind of right there somewhere. 2.74, or what's the other one? We have 3.51, so that's way over here. We don't want that one, so let's take this one. So our speed at that point is 0.9. Alright, now that we finished that run, I'm not going to really do much more data collection, but I'm going to show you the next one. The next one is going to be the same exact thing, but we're just going to add 100. We're just going to add 100 grams to it. And so now we have 100 grams. We're going to do the exact same thing. I'm going to pull it 10 to 15 centimeters away, press record, let it go, and we're going to measure for 10 seconds. Alright, so now you would do the data collection the same exact way as you just did. And with all that being said, you can figure you've filled out the table now. All you need to do is answer the questions and do the calculations. And so I will see you in the class.